Hey there, welcome, good evening. It's David McDaniel, aka Mac, Director of Cloud Professional Services at Qwinix, as well as the Anthos Practice Lead. So, what I've done is just I wanted to try something out, and I'm about to start studying for my machine learning engineer professional certification with Google. And I thought I'd kind of do a self knowledge test and see where I am on the scale of dummy to expert with very low expectations. So I set up a little test. I made some safety zone on the floor here. You can see that over here. And basically what that is a model, a scaled down model. My webcam is sitting above that, kind of looking down. And I'm using this as a warehouse environment where that's a safety zone, and people need to stay out of that. So the idea is I'm using people, little Lego people, to simulate my warehouse workers, and they are going to trigger the automatic machines to stop if they walk in the safety zone. So basically I'm running a Anthos BareMetal on a couple of servers here in my office. You may be able to hear one of them. I'm running a NVIDIA Tesla T4 GPU, and I'm running basically a Google Cloud AutoML Vision model that I trained. I took about 40 pictures using the webcam and started to understand how to use them for training the model. And once I figured that out, after about 23 images, I got too bored of doing it, and I decided that was enough. I kind of figured I have to start this whole thing over again, redo all the pictures and everything, because I don't know what I'm doing. I identified 138 objects in those 23 pictures. Basically, there's 3 people in each picture. There's a safety zone in each picture, and I have a forklift and a pallet, so I can play with things that are moving around, and maybe some things that are allowed to cross into the safety zone, like the pallet, but not the people. So what I have is that now running on my Anthos BareMetal. So we can see here I've only got one parent node, one worker node. That worker node has the GPU in it. The parent's running Ubuntu 18.04. The worker's running Ubuntu 20.04 for a long set of reasons. But I'm going to try both on the 18.04. But point is, it's BareMetal, so it doesn't really matter. So I might try like even a Debian in a Ubuntu. I've got my pods running here. There's 2 containers in my pod, my computer vision runner, and basically one is the pre-built Google Cloud ML runner, basically, that you inject your trained model that you download from the AutoML Vision console. And the other is about 112 lines-ish of Python I wrote to capture an image on the webcam, convert it to base 64 encoded, send it through a JSON call to the machine learning container, get the response back, and process that. So one thing we can see is I've got a little loop here of NVIDIA SMI. It's a utility that just gets you information about the NVIDIA GPU. I've got the 8 gig model. You can see it's sitting here running at about 26 watts at 67 degrees Celsius. And it's been kind of between 68 and 69 for a while. So it's not super duper busy. And you can see it's changing to between 26 and 30 watts. Anyway, so I did want to go a little bit into the AutoML Vision piece and show you this. So this is where I came to figure out what kind of model I could use. And I came in here, and you can see I have my data set, but basically what I did was create a new data set, and it lets you choose what kind of model you want. Single label classification, multi-label, or object detection. So this allows me to say, I want the model to identify the various objects it sees based on the training from the real-time video feed. So that's what I did. I went in and loaded 23 different images with about 138 identifications, as you can see, of my various objects. So as you can see here, for example, I've identified the forklift, the pallet, the safety zone is here, and it basically allows me to determine if any of these things, including the persons, are in or out of the safety zone. Not through the model itself, but through its identification at runtime of a person and the safety zone. It gives the coordinates of the safety zone, so I can then compare coordinates of the person compared to the safety zone. And if we look at the evaluation, it wasn't that good. And this is one thing that surprised me. I mean, it says it's got 100% precision, but there were 2 total test items. So that did not give me a ton of confidence. And you can see as the recall went up, the precision went down. So I was a little worried that I was not doing enough and it was going to fail miserably. So just to show you here, this is kind of neat. I've got all my Kubernetes clusters or Anthos clusters here. I've got my one on-prem here, Anthos. That's just off right now. That's the one that runs on top of VMware. And I've got my GKE on AWS cluster, or Anthos on AWS. That's running and in AWS. And then I've got my cloud ABM, the Anthos BareMetal. And that is running on my physical machine in my office here. So I don't think I showed you this. This is my QBMQ. And basically this is my computer vision init and runner. The runner is the 2 containers, one with the model and one with the webcam interface. And then the init basically just copies the model to a persistent volume in my cluster. So if I've ever updated my model, I could literally just replace it on their persistent volume by rerunning this container or this pod and update the model in real time. All right, what we're going to do here is try a couple tests. First with my pallet. I'll put that in the safety zone and see if anything triggers, and then we'll try with the person. So we'll start up a little listener here. It's listening for messages that are coming in via the QBMQ. I'll try the pallet first. And you can see down here on the left, that's my phone, video from my phone to show the safety zone. So I've put the pallet in there and there's no reaction from the queue. So now what I'll do is put a person in there. And you can see, even before I could sit up, we're now getting lots of events. Person leaves the safety zone, no more events. So I just wanted to kind of record what I did and say that it was surprisingly easy and surprisingly accurate, given I had 23 images. So you hear a lot about using thousands of images, and in a real environment you probably would want to. But this has been a fun experiment, and I hope you learned something. You can always reach me at mac@qwinix.io. Thank you and have a great day.